Okay, we're given the equation in messed up form of a hyperbola. 9x squared minus 25y squared equals 225. We're asked to find the foci and the sketch. Now, we had two notes to describe the equations of the hyperbola. And this one has the x term, the x squared term positive, and the y squared term negative. That fits out of notes 148 and 149, the one that has the x squared positive, that's the note 148. So look back at note 148 and see that the standard equation is of the form parenthesis x minus h parenthesis squared over a squared minus y minus k squared over b squared equals 1. So it looks a lot like the ellipse, except that one of the terms on the left side is positive and one is negative. And in this case, we know that the x term is going to be positive because the given equation has the x squared term positive. Okay, so let's try to get our equation that was given to us in this form. First of all, let's concentrate on this guy right here. The right side has to be equal to 1. Here it's equal to 225. So we're going to divide both sides by 225 in order to get the proper form. X squared minus 25 over 225 y squared equals 225 over 225, which of course is equal to the 1. That's why we did this. This is why we divided by 225. So what I want you to notice is that 225 can be factored. It factors down as 9 times 25. So if you cancel a factor of 9 on the top, it's going to leave 25 on the bottom. If you factor a cancel of 25, cancel a factor 25 on the top, it leaves 1 on the top, but it leaves 9 on the bottom. So we end up with this form, x squared over 25, which we'll write as 5 squared, minus y squared over 9, which we'll write as 3 squared, equals 1. I'm going to put a box around this because this is I know they didn't ask for the equation, but it's so important. Now, you see what this tells us already? It tells us that the center, hk, the number being subtracted from x, the number being subtracted from y, it's just 0, 0. It also tells us that the number being squared under the x term, that's what we call a, is equal to 5, and b, the number being squared under the y term, is the number 3. All of that information for free, just like getting the proper standard equation. Okay, so we need to find the foci, and we can do that. Well, should we start the sketch now? I guess that wouldn't be a bad idea. Let's do that. Here's our y-axis. Here is our x-axis. We'll go out to A. Oh, the center, of course, is here at 0, 0. Let's go out 1, 2, 3, 4, 5 units. That's our A distance. And then on this side, it will be out to negative 5. And then we're going to go up 3 units about here. And down below, 3 units about to here. That's negative 3. Okay. And we know that we are ready to embed a box. So I do it with dotted line. Going to make a box. Coming straight down through the negative 5. And over here through the negative 3. And straight down through the positive 5. Okay, there's our box. And then we're going to draw our asymptotes by sketching a straight line from the corner to the corner. Dotted line, passing through the origin or the center, wherever the center is of your hyperbola. Corner to corner, passing through the center. Probably should use a ruler here to be more accurate. Okay. Since the y term, the y squared term, is the negative term, that indicates to us that this looks like note number 148, which means it's opening right and left. Opening right and left. So it's going to be passing through the negative 5 and the positive 5. and it's going to be asymptotic to the x marks the spot asymptotes. And here, we're passing through the -5, and we're asymptotic to the asymptotes. And extending the the x-axis, we know the vertices are going to live just a little further out. Okay, so this is my v sub, I don't care what we call it v sub 1, and this one will be v sub 2. This is going to be my f sub 1, because we have to wrap around our focus, and this would be f sub 2. And of course we have the horizontal major axis. Let's identify the different distances here. This is called my A distance, A. This is called my B distance, B. And the distance connecting this embedded right triangle, that is called my distance C. Okay, let's pull that out, the right triangle. The right triangle looks like this. That's my distance B. This is my distance A. This is my vertex here at the end, V. And connecting these two together is my distance C. But that distance C is important to me because, look, this is the same distance C to locate the focus. Okay, so let's work with this right triangle. What do we know about B? We can look at the sketch and see that it's equal to 3. What do we know about A? We can look at the sketch and see that it's equal to 5. We can use Pythagoras to figure out, to find C. Hypotenuse squared equals leg squared plus leg squared. So C squared equals 3 squared plus 5 squared. C squared equals 9 plus 25. C squared equals 34. So C is equal to the positive square root of 34. Now that's important. I'm going to put a box around that because that is going to tell me the location of my focus. Looking back at that mess of a sketch I have above there, it tells me the following, that my focus, I'll just write them both in one statement, the foci are going to be equal to plus or minus the square root of 34 for the x-coordinate and 0 for the y-coordinate. Okay, let's clean up our sketch for our final picture. It looks like this, and over here at 5, it wraps open approximately like this, and over here at -5, it opens like this. Whoops. And we are finished.